Guys, welcome to YouTube channel Foundation JEE. Today lecture is based on differentiation, which plays a vital role while solving the maths as well as physics problem too. Okay, in this lecture we will first see the definition of differentiation and then see what does mean by differentiation of a function and what is its meaning. Okay, then we see various rules which are being followed while solving the maths problem. Okay, the rules which are being discussed in this lecture are constant rule, power rule, product rule, chain rule and quotient rule. Okay guys, to understand the differentiation of algebraic and trigonometrical function, we will also see how to make a differentiation of such type of functions. Okay, so guys, first we start with the definition of a differentiation. Now definition of differentiation. Okay, differentiation, the rate of change of a quantity or dependent function with respect to an independent variable is known as derivative. The process of finding derivative is called differentiation in maths. Okay guys, here I used the word dependent function or the second one independent variable. What does mean by this one? Okay, see guys, suppose guys, here d is a displacement of an object which is a function of time, say 2t cube plus 5. Okay, now guys, which one is depend on which one? So you will say here d displacement of an object is depend upon time. Okay guys, the second one t is here variable. Okay, so guys, you know in physics the displacement of a particle is equal to d2, the final position of the particle, and you will take the difference of the initial point of the object, divide the time lapse from going d1 displacement to d2. So this time this will give you a average velocity. Okay, so guys, this one is what rate of change of a object with respect to time. Okay, so in physics this is known as a average velocity. Okay, however guys, in mathematics, suppose here this one is a y-axis and this one is a x-axis. Okay guys, so this one y-axis and this one is a x-axis. Okay, now suppose we have a curve here. Okay, so when a straight line cut this one curve at 2 points, say P and Q. Okay, so this line is known as, in maths, secant line, means a line which cut the curve at the 2 points is known as a secant line. Okay, suppose the coordinate of the point is x1 comma y1 and this one coordinate is x2 comma y2, then guys, what you read in coordinate geometry, which lecture has been already uploaded in foundation JEE channel, the link of that video is given in the description box for more clarity how to take a slope of a line. Okay, now guys, in this case the slope or gradient of line, say PQ, okay, equal to the difference of the y coordinate of 2 points, and when you divide this one by difference of the 2 points x coordinate, then it will give you what guys? The slope of the line. Okay, what basically here happening, see, this one is a triangle if guys, or this point is here x1 comma y1, or this q point is x2 comma y2, so vertical distance will be y2 minus y1. Okay, and the in this case horizontal distance, or you can say base of this triangle, is x2 minus x1, or this one is theta, then tan theta equal to the perpendicular distance, this is P and this is B. Okay, so this is y2 minus y1 or x2 minus x1. Okay, so guys, you can say, sir, what is use of this one here? Okay, see, suppose this secant line again cut this curve at 2 points. Okay, say this is M and N. Okay, so again suppose the secant line just touches this one. Okay, now say this point is guys now a point, okay, whose coordinate is x3 comma y3. So what you see here guys, if we are interested to find the slope of this line at this particular point, then how could you find this one? Okay, so you can say, sir, only you have a one point here, then how could you find the slope of this line? Okay, so here guys we use the derivative, or you guys say differentiation method for finding the slope. Okay, see how it works. Okay, suppose guys here you have a point x3 comma y3. Okay, so a point has a coordinate here guys x3 comma y3. Okay, now guys, if guys you will say, sir, this one is a curve, suppose it is a function of fx, or you can say this is like x square minus 2. Okay, so what you see guys here, this x3 and y3 point must satisfy this function. Okay guys, so at this time what you say, sir, we can write this one fx3 equal to x3 square minus 2. Okay, and now suppose guys we take another point here. Okay, say here in this case this one is here y3 point. Okay, now suppose there is another point which is like this x3 plus delta x. Okay, or this has x coordinate equal to x4, or this delta x is very small, suppose this delta x tends to 0. Okay, means the delta x value is so small, that is it is approximately 0.00000 and so many zeros then 1. Okay, so what you see guys, you will get another point x4. Okay, so you can say this one also satisfy this curve. Okay, so at this time what we write here, x4 equal to here guys fx4, or you can say, sir, this will also satisfy this one, then we can write like this one. Okay, so now guys you have a b point coordinate x4 comma y4. Okay, so what we do for this time, taking a slope of the line. Okay, when you guys have a two coordinates. Okay, see here slope at point A can be written as y4 minus y3 divided by x4 minus x3. Okay, so guys here slope, okay, of point A, okay, is like this one, okay. So in mathematics, when you take a limit or say delta x tending to 0, or this one y4 minus y3, or this one x4 minus x3 equal to, here guys, we can say dfx by dx, okay, will give the slope of the line at a particular point, okay. What is here basically happening, you have a vertical distance between the 2 points, this one, and now this one is a horizontal distance between the 2 points. When you divide these two quantities, then this one is tangent of the curve at point A, okay. So guys, if we say limit delta x tending to 0, it means the next point nearer to this case here x3, okay. So we can write it as a x3 plus delta x minus f x3, or take a difference, then x3 plus delta x minus x3, okay. So x3 cancel out, so this one limit delta x tending to 0, or fx3 plus delta x minus fx3, or this is delta x, okay. Or you can also say, sir, this one can be also written as the variation of the y coordinate is here delta y, or this one is delta x, or this is limit delta x tending to 0. So we can write it as here dy by dx also, okay. So what you see, when the difference between the y coordinate is very small and divided by the small variation of the horizontal distance between these 2 points, which is very small, then this time it will give you the tangent of the curve at a particular point, okay. So guys, see here what will be the slope of this one, okay, or you can say what is the derivative, okay. Because in mathematics, when you write any function like this one, okay, dfx by dx limit delta x tending to 0, or f here x3 plus delta x minus fx3 divided by only delta x, so this is known as derivative. So dy by dx here known as derivative, okay. Or here y is here function of, in this case, x square minus 2, okay. Now guys, how to find this derivative, or you can say slope, see here d fx by dx equal to, guys, the final value is here, in this case x3 plus delta x whole square minus 2, then minus sign with x3 square minus 2, okay, or divided by delta x, or here limit delta x tending to 0, okay. So 2x3 delta x plus delta x whole square divided by delta x, or limit delta x tending to 0. So you guys write it as a limit delta x tending to 0. This arrow sign is guys known tends to, okay, or here what we write 0, okay. So we can also write it as a 2x3 plus delta x, okay. So what you see, if you write here delta x tending to 0 means delta x is so small it can no going to make change of this one, okay. Suppose this value is 0.000000 and so many zeros, then finally it is coming 1, okay. So we can write this value, suppose like this one, okay, so many zeros, and this is what finally you can say, sir, we can write it as a 2, yes. So this one is here 2x3 value, okay. Now so what you see guys here, if we know x3 value of point here x3 comma y3, then we can find the derivative or tangent of the curve at a particular point, okay. So here we have considered x3 as a particular point. So in general case, suppose our equation fx equal to x square minus 2, so d fx by dx equal to guys 2x, okay. So x may be any three, x5, x6, and so whenever you put the value of the x, then at that particular point you can get the tangent of the curve at a particular point, okay. So this is also guys known as a derivative of a function with respect to x, okay. So guys you can say, sir, we whenever we need to find a derivative of a function, so we have to do all these exercises. So my answer is guys no. If you guys know the certain rules of differentiation or how to find derivative of a function, then you don't need to do all this exercise. Then you can say, sir, what are those rules, okay. So see the rules which are being used for finding the derivative of a function, okay. See, constant rule of differentiation. So what this rule says guys, suppose here if a k is a constant quantity, okay. Constant means what guys, suppose this one is 4, 5, okay, or it is not varying with any independent quantity, okay. Suppose guys here f of x equal to here suppose say 3 sir. Okay, so what will be the derivative? So you can see in the right hand side of this function 3 there is no any independent variable. So whatever the value of the x changes here, suppose this is equal to x equal to 5. Okay, then this value is 3. X equal to sir say 7, then again f7 equal to also 5. So what you see here, this function is not going to change when the x value is changing. So this time when you take the derivative of such type of function, then this is equal to 0. So you can say in general, when d any constant number or quantity, or suppose here variable is x, so we can write it value is 0. So this is guys known as a constant rule of differentiation. Okay, the second rule is a power rule of differentiation. Okay, so what it say? Okay, it says guys, suppose here fx is a function like this one, a is a constant number, or it is a function like this one. Okay, means power rule, means see here x to the power of n, so n is a power of x, so this rule is known as a power rule. Okay, now guys, how to take differentiation of a such function. Okay, so in mathematics it has been decided that whenever such type of function is coming, so you can write it as a then multiply by n or x n minus 1. Okay, so you can say this one equal to na or x n minus 1. Okay, so whenever such type of question is coming to find out the derivative, the value is this one. See this one by an example. Suppose guys fx equal to 2 to power of x3. Okay, so what will be derivative in this case? So we can write like this one, derivative of fx with respect to dx, okay, equal to 3, means the power of x is 3, so 3 into 2, then x, then 3 minus 1, so finally you can write 6x square. Okay, so this one is the derivative of this function. Okay guys, one more example you see for a power rule. Okay, a function is like this one. Okay, root over x, or this is 2. Okay, so then in this time how could you take a derivative? Okay, so guys, we can also write it as a 2 x to the power of 1 by 2. Okay, or if this x is going from denominator to numerator, then we can write it as a x to power of minus 1 by 2. Okay, so how this is happening, you can see, suppose here we write it as a this one. Okay, if we multiply x to power of minus 1 by 2 in numerator and also in denominator, then what you see, this value is 1. Okay, so we can also write it as this one. Okay, and then the x is same, so you can write it as this one. Okay, so finally what you see, this value is coming x to power of 0 in denominator. So in mathematics this is a convention where there is a finite number or any value and its power is raised by 0, then this value is 1. So finally this is equal to x to power of minus 1 by 2. So this is the reason I have written this function like this one. So you can see here, now the power of x is what guys? Minus 1 by 2. Okay, so you can easily find out the differentiation of this function. So you can say, sir, what will be the value of this function? Okay, see here. So dfx by dx equal to minus 1 by 2. The power term is here minus 1 by 2. So we can write it as a minus 1 by 2. Then next one is 1 by 2 coefficient of this x to the power of minus 1 by 2, or then again x minus 1 by 2 or minus 1. Okay, so again guys, what we write, it is equal to minus 1 by 4, or this is x to power of minus 3 by 2, or you can further write it as a x to the power of 3 by 2. So this one is your solution. Okay, this way you can utilize power rule for finding the derivative of such type of function. Okay, now guys, see our earlier this one, fx equal to x square minus 2, can we get the final result 2x? Okay, which we found by taking a limit 1. Okay, so now apply these two rules for finding the derivative. Okay, see what is the result coming. We can write dfx or dx, or further we can write x square minus 2, or this is dx equal to dx square or dx. Okay, so we can simply write here a minus sign, then d the d2 by dx. So what we are doing, we can take a derivative separately. Okay, so now guys, you utilize the power rule here. So we can write it as a 2 is in power of x. So 2 is coming first, then x, then 2 minus 1, or the constant rule says if this is constant of derivative of variable, then this value is guys what? Now 0. So finally what you get? This value is 2x. So finally you see the derivative of this function is coming this one. So whenever guys you need to find a derivative of a function, you don't need to do all this exercise. Okay, or you can say whenever you need to find a tangent of a curve at a particular point, then you can use this derivative method. Okay, suppose if this function is like this one, okay, or sine x to power of 2. Okay, so whenever you go for your convention method, x plus delta x see this one how much complicated. Okay, for this one. Okay, so if that time you will take like this one, so this will take how much time for solving this problem, or you can say derivative of this one. Okay, so we can also solve this one later by derivative method. See this one. Okay, so only I have done all these exercises for your understanding how the derivative of function is being taken. Okay, now the second thing, guys, in physics the rate of change of the function can also, we can say, this will give you the instantaneous rate of change of that thing. Okay, in our question, if suppose a particle is a function of ft and say this is equal to t to power of 3 plus t, or this is minus 1. Okay, so what will be its instantaneous change of rate with respect to time, which will give you the instantaneous velocity. Okay, so in question it may be asked, find out instantaneous velocity of object or particle at t equal to 3 seconds. Okay, so we can use our derivative method. Okay, basically what here this one give, so in physics you know, when you divide change of displacement divided by time lapse, then this will give you the velocity. Okay, but guys, when you want to find a instantaneous change, then you must use this one. Okay, so what will come in this case, guys? See. Okay, so we can write it as a like this one, dt3 by dt, separate each term individually, or write a sign whatever given it in coefficient of this one. Okay, so this one positive coefficient, this is coming plus, here minus coefficient, then write minus, then 1 by dt. So use a power rule here, 3 then t, or when you subtract 3 minus 1, so this is 2, or this is 1, guys. Okay, or here power of t is 1, when you subtract 1 minus 1, then this is 0. So this one is our final answer, 3t square plus 1, or guys this is a constant one, so this value is minus 0. Okay, so this is our final rate of change of this particle with respect to time. So at any times, here question is asking t equal to 3 second, then what will be its velocity? So simply put here 3 into 3 to power of 2 plus 1. So what will come, guys? This is 27 plus 1. So you can write it as 28. Okay, so this way you can use this derivative methods in physics for solving problem. Okay, this one is a one particular case where the differentiation is being used for finding the instantaneous velocity of the object. Okay, so next one, guys, we have to find a derivative of this one. Okay, So finding the derivative of this one, guys, you know some more rules of differentiation, then you can find the derivative of such type of function. See what are the rules. Okay, the next one rule is, guys, a product rule. Okay, see what it say. We can write here first fx equal to x3 or sine x square. Okay, we will take a differentiation with respect to x when we learn more differentiation rules. Okay, see, third rule of differentiation is, guys, product rule of differentiation. So what is this product rule? Okay, this rule says, guys, suppose fx is a function which is a multiplication of two functions. Okay, so this time dfx by dx equal to, guys, u of x d of vx, or this is dx, or then plus sign v of x then dux by dx. Okay, you have a function here ux equal to x and vx equal to, say, cos x, then you can write fx equal to x cos x. Okay, so differentiation of this one we can write f of x dx, okay, equal to, guys, we can write x then differentiation of cos x then dx then plus sign then cos x, or this is dx by dx. Okay, so what we say, the differentiation of cos x with respect to dx is coming minus sin x. So put a minus sin x then sin x, or this is coming cos x. Okay, so guys, you can say, sir, how the differentiation of this one is coming this one. Okay, so for this one, you guys, you must remember some trigonometrical formula. Okay, which is most important for you. First formula, sin a plus b, the first formula, sin a plus sin b equal to 2 sin a plus b divided by 2, or cos a minus cos b divided by 2. Okay, and if sin a minus sin b is coming, then it is equal to 2 sin a minus b by 2 into cos a plus b. Okay, so guys, suppose you have a remember this one or you forget this one, so one trick you remember, we can write minus sin b equal to sin of minus b. Okay, so if we put this value here, plus b becomes minus b, or minus b becomes here plus b. Okay, so you can also write it as a sin a plus sin minus b. Okay, so you can write sin a, then here b value is what, here minus b by 2, or this cos, or a then minus into minus b. So what you write it as a 2 sin a minus b by 2, or this is cos a plus b by 2. Okay, so this one is a trick. When you remember this one, you can find the second one. Okay. The third one rule, cos A plus cos B, then you can write it 2 times cos A plus B divided by 2 or cos A B by 2. Okay. Or guys, suppose this is cos A minus cos B, then what will be formula? So you can write it as a cos A plus cos 180 degree here minus B also. This will come minus sine 2 sine A plus B divided by 2 or sine A minus B by 2. Okay. So this one is a formula which is being used here for finding the differentiation of cos x. Okay. See how it can be used here. Okay. So we can write limit delta x tending to 0, a function is changing to x plus delta x, or this is minus cos x, or this is coming delta x. Okay. Or this will give you d here vx by dx. Okay. So when you write this one, so you can write here limit delta x tending to 0, or this is minus 2 sine x plus x, so 2x plus delta x by 2 or sine delta x by 2, or this is coming delta x. Okay. So what you see guys, when you put the value of delta x is 0, so this is becomes 0 by 0. So in mathematics it is known as a indeterminate form. Okay. So in this case, how could you take a limit? Okay. So in limit we will study later one rule which is known as a L'Hospital rule. So what this rule say, which is cause for the 0 by 0, take a separate this one and take a limit one. Okay. So whenever you will put this value again, this is coming 0 by 0. Okay. So take a differentiation of the denominator separately and take a differentiation of numerator separately, or then put their values. Guys, which one is here responsible? Delta x by 2 or delta x is responsible for 0 by 0. So what we can write here, guys, take a differentiation of this one separately. Okay. So what will come here? You can write it as a d sine delta x by 2, or differentiation with respect to delta x, and d delta x by delta x. So this will come 1 by 2, or this is cos delta x by 2. Okay. Or this one delta x power is 1, so we can write it as a 1. Okay. So finally what you get, 1 by 2 cos delta x by 2. So in this time, when you take a limit of this one, limit delta x tending to 0, now you can see this minus 2 sine 2x plus delta x by 2 can be written now as a cos delta x by 2, or this is 1 by 2 multiply, or this term is 1 here, so we can put the value. So when you put the value of delta x 0, finally what you get, minus 2 into 1 by 2 or sine 2x by 2 plus delta means 0 by 2, or this is cos 0 by 2. So finally this 2 cancel out, or you can say only minus sin x is coming. So derivative of cos x with respect to x is minus sin x. What you see, the differentiation of cos x is coming minus sin x. So this is coming how when you will do all these exercises. So guys, one trick you can just remember, the derivative of this function is coming this one. It can reduce your time, and in examination nobody is going to ask how this result is coming. So if you remember final result of derivative of a function, then it will help you for solving the question, and also guys reduce your time for solving the question also. Okay, so guys, now see the fourth rule of differentiation. Chain rule says here, suppose if gx is a function of any function like this one. Okay, so how could you take a differentiation? Suppose one case here, cos x to power of 5 by 2, where fx guys can be written as a x to power of 5 by 2, then cos of fx. Or now guys, if we say this is also a function of this one, so it is also true. Okay, so how could you find a differentiation? So in this case we can write d of gx by dx equal to d then u or f of x. Okay, or d of f of x, and then d of fx take derivative of this one. So this one cancel out, or finally we are doing the same, but it is easier to find out the derivative. So cos x to power of 5 by 2, or d, or this is d x to power of 5 by 2, then we can write it further x to power of 5 by 2 or dx. So we read just the differentiation of cos x equal to minus sin x. So here see, this one and this one is same. Okay, so this is like this one. Okay, here x is here, also x is here. Here x to power of 5 by 2 is here x to the power 5 by 2 is here. So simply you can write it as a minus sine x to power of 5 by 2. Now you use this one for power rule, into 5 by 2 or x 5 by 2 or minus 1. So this is coming guys here 5 by 2 for this one, then x for x to power of 3 by 2, or this is sine x to power of 5 by 2. So this way you can find the differentiation of this one. Okay, now guys, see now this function. So guys, here see solution of this function. Okay, so if we take a derivative of this function with respect to dx, then first of all we see here this one is assume ux and this one is a vx. Then what we write here, x cube, then differentiation of sine x square by dx, then again positive sign, then sine x square d, then x cube, or divided by dx. Okay, divided by dx means we are taking a derivative of the function with respect to x. Okay guys, so here we can apply guys chain rule for this one. Okay, so x cube equal to d sine x square and again dx square and dx square or dx. Okay, and for this one guys we apply the power rule. What it say, the power of x is here 3, so it will come in coefficient. Then again we write here x, then 3 minus 1, then sine x square. Okay, so next guys we can write here this one x cube or this one cos x square or this one guys 2x. Okay, and this one 3x square or sine x square. So guys finally you can write it as a 2x to power of 4 cos x square or then plus 3x square or sine x square. So if you want to make a further simplification, you can take a x square common, then it becomes 2x square cos x square plus 3 sine x square. Okay, so this one is a solution for derivative of this one. So next we will see the quotient rule of differentiation. Okay, see quotient rule says of differentiation. This rule says suppose fx is equal to ux by vx, then differentiation of such function is equal to draw a big sleeping line and take a square of denominator term and you write then denominator term, take a derivative of numerator term which is ux here, then put a minus sign, write again ux d and vx by dx. Okay, so this is the quotient rule of differentiation. Okay, consider a function fx equal to 10x. Okay, so we can write it as a guys sin x by cos x. Okay, so now apply this quotient rule for derivative of this one. So we can write it as what guys, take a big sleeping line, then square the denominator term, write here cos x, take a derivative of sin x by dx, put a minus sign, then again this numerator term which is sin x, then d again cos x or dx. Okay, so what you know, the derivative of sin x is cos x, so put a cos x sign, or this is minus sin x, or this is minus, or this is minus sin x. Okay, or this is cos square x. What will be final answer? This is coming cos square x plus sin square x or divided by cos square x. So this is equal to 1. You know the cos square x plus sin square x equal to 1. Sir, is it true or not? Okay, so suppose x value is guys in this case 30 degree. So what you know here, this one. Okay, so this one is equal to what guys, root over 3 by 2 whole square plus this one 1 by 2 whole square. So this is 3 by 4 or this is 1 by 4. So finally 1 is coming. So this way you can use this method. Okay, so finally this is cos square x, so we can write like this one also, or this one is equal to sec x or also sec x. Okay, so finally what you will get, sec square x, the differentiation of this function is sec square x. Okay, so you can use the differentiation method for finding the result. Guys, anytime you forget this rule, okay, so how could you check this is ux, this is vx, or this one? So simply what I do in my early study days, if suppose we consider fx, or this one is a 1 by x, okay, so its differentiation is what guys coming, minus 1 by x square by 2. Okay, so what I remember, this value is what, like this one. Okay, so if we apply this power rule, so we can write here d of fx, then minus 1 is coming for the power, then x, then minus 1 or minus 1. So what you see here, this is minus 1 or x to power of minus 2. Finally it is coming minus 1 x square by 2. So whenever you forget this one, or you remember this power rule or this one function value, this is minus 1 by x square, so you can check, have I remembered a correct formula or not. Okay, see, applying this function derivative by this one. Okay, so in this case guys, here we can write the denominator is x, so x square, then put again here x, take a d 1 by dx, because here this is ux by vx. Okay, so derivative of 1 is coming minus, then 1, then d of x by dx. So what you see guys, this constant term value is 0, or this is minus 1, or this is 1, dx by dx equal to 1, because x to power of 1 minus 1, this is 1. Okay, so 1 x to power of 0, so we can write it as like this one. So this is minus 1 by x square. So whenever you forget this one, you can remember this one. Okay, or if in examination suppose this is coming like this one, okay, so you can also utilize this method for solving the problem. Okay, see the solution of this one. Okay, now guys, the solution of this function, root over x divided by sine x square. Okay, so we write equal to, draw a big here slipping line, then square the denominator. Okay, then write down here the denominator term, which is sine x square, then d root over x and derivative of x. Okay guys, then we write a negative sign and then put the root over x, then d sine x square dx. Okay guys, now guys, see, we have left here derivative of this one is dx. Okay, so df by dx. Okay, we read in derivative rule that if a function is like this, then what we will do, we will first write the power of here x. So here power of x is 1 by 2, then sine x square, then we write here x 1 minus 1, or this is 1 by 2. Okay, then the second one is root over x. Then see this one, d sine x square by dx. So we can use here the chain rule. What it say? We write here sine x square derivative of dx square and then dx square by dx and whole divided by sine square x square. Okay guys, then what we write next here, 1 by 2, or this one is x to the power of minus 1 by 2, so this one under root over x. Then guys, this will come into sine x square, then root over x, or here we know the sine x derivative with respect to x is what guys here. If this is sine x or derivative of x, then this time here is x also, here is x also, so this is the cos x. Okay, so we write here next here, this is cos x square, then guys into the 2 power of x square is 2, or this is x, or 2 minus 1, then we divide whole the numerator term by sine square and x square. Okay guys, then what we do next guys, see here this one is sine square x square, then we can write 1 by 2, this is root over x, and this one sine x square will be cancel out, then it becomes sine x then x square. Okay, then again we write root over x, and here see 2 will come and again x, then this will guys also x. Okay, and again we can write it as a cos x square and then sine x square, or this one is also sine square. Okay, so next we can write guys this one equal to 1 by 2 root over x, or this is cos x square, or this one guys 2, or guys we can write it as a 3 by 2. And next one guys, this one is cos x square, or cot x square. How I write this one? You know, suppose this is cos t by sin t. Okay, then this one is cot t. Okay, so this one, now you can also write this one like if take a cos x square common, then 1 by 2 root x, then minus 2 x to power of 3 by 2, or guys then this one cot x square. So this one is a derivative of this one. Okay, so you can write the derivative of this one with respect to dx will come finally this one. So guys, hope this lecture based on differentiation clear to you. So if you think guys this YouTube video on differentiation is informative for you, so one request from you guys, please like, subscribe and share to your friends and family, so also they get knowledge about this YouTube channel, Foundation JEE channel. Okay guys, one more request you guys, if you want to be updated for the next video, please on your notification, then only you will get the update. Okay guys, in next lecture we will see how to make a differentiation of a exponential, logarithm and inverse function. Okay, so thank you once again to watching and listening this lecture. Okay.